Hi, in this video we are going to be looking at some distribution. Already we have some questions here to deal with, but these questions are coming from uniform distribution, and we would like to derive the mean and the variance of this uniform distribution, as well as the mean and variance of other distributions. But in this particular video we are going to be looking at the uniform distribution and exponential distribution. Let's quickly go through the questions we have here. The amount of time it takes Sarah to check out at her local supermarket is uniformly distributed between 0 and 60 minutes. Find A. Sarah's expected checkout time. B. The variance of the time taken to check out the supermarket. And we may not take time to read all the questions here, but let's just take it one at a time. To start with, the first thing we are expected to calculate here is Sarah's expected checkout time. The expected here is also known as the mean. We're talking about the mean of this particular distribution, that is the uniform distribution. And so for us to be able to address this problem effectively, we would like to derive the mean as well as the variance of this particular distribution, because in the latter part of these questions we are going to calculate the variance of this particular distribution. Now let's get started. Remember that the uniform distribution, also known as the rectangular distribution, is distributed between A and B. So let's put that down in order for us to be able to derive the mean. We have to know what the PDF is. Now remember, another name for this uniform distribution is a rectangular distribution. So it is better we use the diagram here that looks like a rectangle. So how does it look like? First, let's put down the PDF. The PDF, which is f of x equals 1 over b minus a, which we are going to show. How do we get here? How are we going to get to this particular place? We are going to show it. And we know that x is uniformly distributed between A and B. So we know that another name for uniform distribution is a rectangular distribution. So showing the diagram here, we know that it looks like this. So if we go from here down to this place, we know that A is somewhere here and B is here, and f of x is somewhere around here. And we know that the area under this curve here, that equals 1. We are talking about the total area. Whenever we are talking about probability, the total probability under any curve, that equals 1. So if we have the total area to be 1, and we are asked to calculate f of x, which is also known as the height, what do? We know that this is a rectangle, and this, if we are going to get our f of x, we will have to calculate the area, which is base times height. And so the area being 1, we know that the base is the difference between the A and B, which is what? B minus A. and our height is simply f of x. So having put this down, we know that f of x has a coefficient which is b minus a, and we bring that here, we divide both sides by the b minus a. And if this goes with this, we know that we have f of x equals 1 over b minus a, which is what we have over here. With this, we can go on to get our mean. And how does it look like? Remember, x is a random variable and it follows a uniform distribution distributed between a and b. And so if we are to take the expected value of this particular x, is going to look like this. In order to make it short, is between a and b, goes from a to b, and then the x we have times the PDF, which is simply 1 over b minus a dx. And since this particular one is a constant, we are going to take it outside the integral. We take it to the front of the integral and integral sign, and that gives us 1 over b minus a integral a to b x dx. And if we continue, we know that when this x is integrated, we are going to have this being this being outside, we are going to have x squared over 2, and that we know it ranges from a to b. And so if we continue with this, we know that b is going to take the place of x and a is also going to take the place of x. That means b squared minus a squared all over 2. So we have b squared minus a squared all over 2. And if we simplify this portion further, if we factorize this, we know we are going to get b minus a and then b plus a. If you expand this, you are going to get back to something like this, but that is all over 2. And so this will cancel this, and we are left with 1 to multiply, 1 and then this b plus a, and if they multiply, we are going to get f of x, we are going to get expected value of x to be equal b, that is ba times 1 is b plus a times 1 gives us b plus a, and then this one here is also 1 times 2, it gives us this. And so we have our expected value here. And remember, the variance of this particular uniform distribution is variance of x is expected value of x squared minus expected value of x all squared. And remember, we have obtained this particular one, which is this. And so we are going to go for this one the same way we went for this particular one. The difference is that this one is squared. And so let's go the same way we went, to get this other one. So we have expected value of x squared equals integral a to b x squared, and we have 1 over b minus a dx. And so this again being constant, we take it to the front of the integral sign, and we have 1 over b minus a, and we see how the integral sign a to b x squared dx. And so if we continue, what are we going to get? We have 1 over b minus a. If we integrate this very one here, if we integrate this, we are going to get x raised to the power of 3 over 3, and that ranges from a to b. And like we did before, we are going to have b cubed minus a cubed all over 3. And this looks different from this particular one. And so because this one has a power of 3, both of them, have the power of 3, we are going to take one out, so we can be left with the power of 2 for each of them. And how do we do that? We are going to say b minus a, then we are left with b square and a square on both ends. And so this will give us plus ab plus this. And so everything over 3. So what are we going to do from here? We can see that this is similar to this, so they get cancelled. And now we have 1 to multiply this top, which leaves us with expected value of s squared as b squared plus ab plus a squared all over 3. Now we have obtained this and this. This is this, and this particular one here, this one here is this. So substituting, we are going to get variance of x equals this particular one, b squared plus ab plus a squared over 3 minus, we have b plus a over 2, that is going to be all squared. And so if this one remains the same, we have ab plus a square all over 3. And if we expand this, and if we take the square of this, if we square this one, the way it is here, if we take the square of this, we have b square plus 2ab plus a square all over 4. If you open that up, that is what you are going to get, because this square is going to affect everything at the top and bottom. And so our LCM being 12, the LCM of 3 and then 4 being 12, here we are going to simplify this further. If 3 divides 12, we know we have 4, and if 4 multiplies everything on this side, we are going to get 4b squared plus 4ab plus 4a squared, and minus this minus, we are going to use this minus, we are going to distribute this minus, because if 4 divides 12, we are going to get 3. And if the 3 comes outside and then we put this in brackets, remember the minus is going to affect the positive signs, this plus we have in this bracket. And so 4 to divide 12 is 3. 3 times this, the first minus and then the first this, they all give minus. And we have minus 3b squared. Then minus and this gives us minus 3 times 2, 6ab. And minus and plus gives us minus. And we now have 3a squared. And this we can see that this b squared is also found over here. So we have 4 of them and 3 of them. So 4b squared minus this, that leaves us with just b squared, and 4ab minus 6ab, that will give us minus 2ab. And so this 4a squared minus 3a squared, that leaves us with a squared all over 12. And so if we factorize this, since we have b and a on both ends, we are going to get b b minus this a, this b minus this a, just the way we did this one before. Remember, it's plus, and we are getting plus for each of them. But in this case, we have minus coming first. So we just pick b and a. Remember, both of them are squared. So we pick b and a. But the minus comes first, so we put the minus and we square the whole of that, all over 12. And this will give us the variance of x. If this gives us the variance of x, what do we do to get the standard deviation? Standard deviation is just simply the square root of the variance. And if you simplify that further, this will get cancelled with this. We know it looks like b minus a all squared all over root 12. And if this cancels this square cancels the square roots, we are going to be left with b minus a all over root 12, which leaves us with the standard deviation. So having found our mean and then variance of this particular distribution, we are going to go back to our questions and then try to address them one after the other. Remember, we are still going to derive the mean and variance of exponential distribution. But let's just use this. We have got these ones we have just found now to address the problem we have here, which is this. Remember that the amount of time it takes Sarah to check out at her local supermarket is uniformly distributed between 0 and 60 minutes. Now notice that the uniform distribution, like I said before, is distributed between A and B. Here in this case, we have this one between 0 and 60 minutes, as 0 being A and 60 being what? B. So we can see A and B here. So what do we do with that? They are asking us to find the expected values, Sarah's expected checkout time. And so what do? We know expected value is also known as the mean, which we found earlier to be this particular one. So how do we do that? So we are going to say A, the expected what? Checkout time will be one, that is B plus A all over 2, which is 60 plus 0 all over 2, and that gives us 30. So that is the expected checkout time. And the second question says the variance of the time taken to check out at the supermarket. And remember, we found our variance to be this particular one. Our variance is this particular one. So what do we do with that? All we do is just write, that is B now. Our variance is variance of x equals B minus A all squared all over 12. And we have B is 60 minus 0, that all squared all over 12. And we know that 60 minus 0 is 60, all squared all over 12. And 60 squared, we know that 6 squared is 36. And then this 0 will give us this all over 12. And if 12 goes in 36, we know we are going to get 3. And these zeros will follow. So that gives us 300. That is the variance. Now, the next question. The next question says, you find the probability that Sarah will take less than 20 minutes to check out. Less than 20 minutes. I see. Probability that X is less than 20 minutes. Well, let's draw the diagram where we started. If we have the diagram looking like this, and we know that our f of x, if we are to go back to our f of x, so we have not obtained the f of x, we got to be 1 over b minus a. 1 over b minus a, that is our f of x. And now we know that 1 over 60 minus a equals 1 over 60. That is our f of x over here. And this is a rectangle. We know that a is 0 and then b is 60. And what we are asked to calculate here is x less than 20. Let's say 20 is somewhere around here. And if 20 is somewhere around here, less than 20, that will be the area to the left because it's less. The area to the left, and that again gives us a rectangle. And in order to calculate this very one, we simply calculate the area of this very shape. And that again is going to be base times height, which is going to give us probability of x less than 20 equals base is 20 minus 0, which is the same as 20, times height, which is f of x, and is 1 over 60. Remember, f of x is 1 over 60 in this case. No more f of x because it's already known as 1 over 60. And so we have this. So if this, multiplies the top, we have this. And if this cancels, we have 1 over 3, which simplifies to 33.3%. That is, if we are to multiply by 100, want to leave the answer in form of percentage. And we know that this particular one is going to be the probability that Sarah will take less than 20 minutes to check out. So we have seen that it takes Sarah 33.3% to check out of her time, to check out of. Okay, let's not get the whole thing confusing here. Let's go to the next question. We have the probability that x lies between 20 and then 36. That is D. Probability that x lies between 20 and 36. And that again, the diagram will help us. If we do this, we know this is 0, this is what? 60. And this one is 1 over 60. And if this is the case, we know that 20 is here, 20 is somewhere here, and let's say 36 is also somewhere around here. Between 36 and 20, we also have a rectangle. And remember, just to calculate this, we also have a rectangle here. To calculate this is simply base times height. And the base is this minus this, which is going to give us 16. So probability that x lies between 20 and 36, that equals 16 times 1 over 60, which leaves us with 16 over 60. And if we simplify that further, to give us 8, to give us 30, 2 will give us 4, 2 will give us 15. And if we simplify this further, let's say we are multiplying it by hundreds just to get, leave our answer in form of a percentage. We know, you find out what that is going to give us. So when you multiply by 100, you should get your answer. Now, E part, you have question, let's move to the E part of the question. You have to find the 85th percentile. And again, the diagram, if we are to find the 85th percentile, we have the diagram here. And it looks like this. Let's say we have 60 and we have 0. And this one is 1 over 60. We know the mean we have found to be 30. And if you check, if you average this 60 and 0, is actually going to give you 30. Like 60 plus 0 divided by 2 will give you 30. So the mean is somewhere around here, which is the 50th percentile. Now, if we remember, we are going for the 85th percentile as it stands here. The 85th percentile, that is the E part. They say we should find the 85th percentile. And so if we are going to do that, we start from the mean. The mean being the average, as in the midpoint between this range of values. So if this is it, then we know that this one and this one should give us 15. And 15 here should be the 25th percentile. 25th percentile. And if we add the 15 to this, we know the 75th percentile should give us 45. But we are looking at the 80. This one is a 100th percentile. What we are doing in a nutshell is, this is a rectangle, for instance. If I divide it into 2, I have 50-50. Then if I divide it into 4, I have 25, 25, 25, 25. And so 25 is the first one. If you move further, one will give you 50, this one will give you 75, and this one will give you 100. But we know that 85 is just somewhere in between this 75 and 100. And so 85 percentile is what we are asked to find. What will that equal? So let's call that K, or any letter at all. And we know that that area falls to this side. So it's going to be what? Base times height again. And we know that the area to the left is going to be what? Base times height. Area to the left already is 0.85 equals base is K minus 0 and height is 1 over 60. And if we take this equals K minus 0 is K, we have K over 60 if this K multiplies this. And if this 60 multiplies this, we are going to get we are going to get K equals 60 times 0.85, which is the same as 60 times 85 over 100. And if this cancels, this is 5, this is 3. And so if this multiplies this, you work that out, whatever it gives you will be your answer. 3 times 85 divided by this, whatever it gives you, that will be your answer. So if we are to move on to the second part, the F part, we have standard deviation. We have to find the standard deviations. But simply, standard deviation is simply the square root of our variance, which we found to be this. So just take the square root of this and you get your standard deviation. Just the way we derived the formula that time. That's it. That is what standard deviation is all about. So the second to the last question is G part. Given that Sarah has already spent 15 minutes at the checkout, find the probability that she will spend less than 20 minutes to check out. Well, let's just quickly address that. How do we do that? Remember, they say given. This is taking us to conditional probability. Now they say, what if they're asking us find the probability that she will spend less than 20 minutes to check out. Probability that X is less than 20 minutes. Given that X is 15. Anyway, let's see how we address this from this area, from this side first. When we have probability of A given B, or probability of any two, let's say probability of A given B, that we know that is going to be probability of A intersection B all over